Good day. So in this video, we are going to discuss how to determine the area between the two curves or a curve and a line. But before we get into that, I just want to jog your memory. You remember we said if you have got a function of x, so this curve x in yellow, we can actually calculate the area under the curve using definite integrals. Like for example, we can actually calculate this green shaded area by finding the definite integral of a function of x dx with the limits from a to b, and that will be the area of this shaded region. So with that in mind, let's discuss how to determine the area between two curves or a curve and a line. Now, in this diagram, we are given a curve that is the quadratic function or a parabola, which is f of x, and the straight line g of x. So we are asked to determine the area that is shaded in white. Now, to do that, we can actually first of all determine the definite integral of f of x. However, if you just do the definite integral of f of x from this point to this point, you are calculating the whole area under the yellow graph, and you'll be calculating another area which we are not interested in, and that is this part here, and you're not interested in actually determining that. So what you do, first of all, you need to find this point of intersection such that when you get it, let's say that will be B, then you can find the definite integral of the yellow graph, and that will include the white shaded region and this yellow part. So then you get that the definite integral of function of x dx from 0 to b will give you this whole shaded area, white and yellow. Now, then you minus the definite integral of the g of x, also with the limits 0 to b dx, and that will give you now the definite integral of gx from 0 to b will give you this area here, the yellow one. So then if you minus that whole area minus the yellow one, then you get the area which is the white shaded region. Some other people, they prefer actually not to find the definite integral of the straight line, because as you can see, this is a triangle. So if you have got the height here and the base, you can actually also do half base times height. Then you don't integrate that, then just minus half base times height. Then you get the area of the shaded region. I hope that makes sense. Let's discuss some example further. Now, in this example, we are asked to determine the area of the shaded region that is shaded in white. So to do that, we do exactly what we discussed in the previous example. So in this one, we want to find this point of intersection first, so that we determine what is this x coordinate. Then we do the definite integral of x bracket 4 minus x minus the definite integral of 3x, then with the limits from 0 and whatever the value of x this will be. So before we do that, we need to find that point of intersection. So to determine the point of intersection, we just equate the two graphs, because at this point, both functions are equal. So 3x will be equal to x bracket 4 minus x, and then 3x will be equal to 4x minus x squared. And then this can be simplified further to be x squared minus x is equal to 0. Then you can solve that quadratic equation, and that to give you x is equal to 0, which makes sense, and that is that point of intersection of the two graphs, and also x is equal to 1. So which means this point here is 1. Once we get that, then we can actually do the definite integral of the x bracket. So that will be the definite integral of 4x minus x squared dx from 0 to 1 minus the definite integral of 3x dx also from 0 to 1. Then the integral of that will be 4x squared divided by 2. So then that will just be 2x squared minus x cubed divided by 3. Then with our limits 0 and 1 minus the integral of that, that will be 3x squared divided by 2. Then with our limits as well, 0 to 1. And then we just do function of 1. So in this case, the function of 1 will be a 2 minus 1 over 3 bracket minus the function of 1 will be 3 over 2 in a bracket, because we don't do the function of 0 because it's just going to be equal to 0. And then when you simplify that, the answer will be, so then the answer will be 1 over 6 after you simplify that. So that will be the answer. You can just say u squared to symbolize units squared. I hope that makes sense. Now let's look at another example. Now, in this example, we are asked to determine also the area of the shaded region in white, which is bound also by the parabola 3x minus x squared and the line y is equal to negative x. So what we need to do first here, we can actually determine this point. Then we can first of all determine this area under the curve, this part here. So once we determine that, then we can as well, after that, determine this other part, which is the shaded region underneath here. So we also need that point of intersection, so that when we get this point here, the value of x here, so that when we do the definite integral of the y graph, then we get the whole area. Then we do the definite integral of the yellow graph, then we get this part here. Then when we get that part, then we just minus it, then we get the unshaded, then we add that to this bigger part here. So first of all, let's get the point of intersection to the x-axis. So with that, we let 0 is equal to 3x minus x squared. Then we can say 0 is equal to, in this case, we can just factor out x. Then that will be a 3 minus x. Then we can say 0 is equal to x, or x is equal to 3. So at that point, the value of x is a 3. Now, once we get that, then we can find also the point of intersection of the yellow graph and the green graph. So that will be negative x is equal to 3x minus x squared. And that can be simplified further to be x squared, then minus 4x is equal to 0. Then we can simplify that to get x equal to 0, or x is equal to 4. So we know that x is equal to 0 for sure. They are intersecting here. Then, but this point, that will be a 4. So once we get that, we have got everything. So first of all, remember, we determine this region here, this one, which will determine by the definite integral of 3x minus x squared dx with the limits 0 to 3. And that will give us, in a square bracket here, 3x squared divided by 2 minus x cubed divided by 3. And our limits, they should be 0 to 3. Then we do the function of 3. Then we get 3 bracket 3 squared divided by 2 minus 3 cubed divided by 3. There's no need to do the function of 0 because it's just going to give us a 0. So once that's simplified, it will give us 9 over 2. So the area of this part is 9 over 2. So after that, then we want to do the area underneath. So that will be now the area bound by this green graph minus the yellow graph. Then we get this part. Then we add that to 9 over 2. So to do that, we find the integral of negative x dx with the limits. Remember now that is 0 to 4 minus the integral of 3x minus x squared dx, also with the limits. Here now the limits, we want to find this part only. So it's the limits 3 to 4. So that gives us negative x squared divided by 2. Then with our limits 0 and 4. Then minus the integral here will be 3x squared again divided by 2 minus x cubed divided by 3. Then with the limits 3 and 4. Then we just do the function of 4. That will be negative 4 squared divided by 2, then minus, then we can put in a square bracket, then the function of 4, that will be 3 bracket 4 squared divided by 4, and not divided by 4, divided by 2, then minus 4 cubed divided by 3, then we close the bracket, then minus the function of 3, in this case that will be 3 bracket 3 to the power 3 to the power 2, divided by 2, then minus 3 to the power 3 divided by 3. Then we get the answer there. Okay, so this one, the first one gives us the part negative 16, then minus in a bracket here, it gives us negative 11 over 6 for the area, this the yellow part. So one thing that you want to do, you don't want to simplify it like this, because this negative just means that the area is underneath the curve. So you don't need that to solve that. So you just remove that negative. So it really shows that the area is underneath the x-axis. It's on the negative side of the y-axis. So you just use 16 minus 11 over 6. Then that gives you 85 over 6. So once you get the 85 over 6, that is the area of this whole part here. Then this now can be added to 9 over 2. So 85 over 6, then plus 9 over 2. Then that gives you 56 over 3 units squared. Therefore, the area, this whole area, the shaded region, now the diagram is a mess. That whole area will be equal to 56 over 3 units squared. I hope this makes sense, and I hope to see you in the next lesson. Have a great day. Bye.